I thought of making a video presentation about the jet engine. And this, I was trying to find out how a jet engine works, and I had asked many people, and they were, give me convincing answers. So I tried to do some research on it myself, understand it. I want to research, understand it myself, how aircraft engines work. More precisely, the modern day jet engine, which is said to be a discovery or invention of a man, Sir Frank Whittle. Planes used to run with propeller driven mechanisms, primarily run by IC engines or by gas turbine engines. Modern day jet engine is also a gas turbine engine, but with a difference. It uses a slightly different principle, which I found on various platforms are not being portrayed in the way it should be portrayed. If you were to see a jet engine, people would say, well, it has got three stages: the compressor stage, the compressor stage, the combustion chamber stage, and the turbine stage. Right? It's right. But that's not the starting point of a jet engine. Starting point of a jet engine is a totally different kinds of a concept. It's a very simple thing. A modern day jet engine is basically a wind turbine. I'm sorry, not wind turbine. Please remove that word turbine. Is a wind tunnel. Please remove the word turbine. It's a wind tunnel. But the tunnel is not, it is conical in shape. On one end, the diameter is very high, on the other end, the diameter is very small. This wind tunnel is the starting point of a jet engine as we see today. I hope you can picturize it at a very basic level. Whenever you see a modern day airplane, airplanes work also on propellers, but you say an A320 or what we call Boeing planes, you see an engine attached below the wings. You will see a conical structure, which is the engine. The engine is fed fuel from the wings. Well, we will not go to that. Let us try to understand what the engine is all about. Now, if I were to, yeah, I hope you understood this very clearly. That means it's a conical structure, and it is a wind tunnel. I have not seen anyone using this word wind tunnel in the study of aircraft engines, and I felt very upset about it because we got too much into the technical complexities of things. I was listening to a lecture at the School of Aviation, Indian Institute of Science, Bangalore, some 25 years ago. The learned professor was giving a very good mathematical explanation of various aspects of aircraft. I felt very impressed. But if I were to ask you what is an engine, what is an aircraft engine, it's basically a wind tunnel which is conical in shape. It is not a perfect conical; it's a spherical cone. It's something like that, with a higher diameter on one side and a very small aperture on the other. Let us see how this works. If I were to heat the air inside, now I'm taking the next very nice example. I am trying to heat the air inside. If I heat it at 100 degrees centigrade, nothing will happen. The body of the cone will become warm after some time, and that's it. But if I were to heat it to a very high degree of temperature, I don't know exactly what the temperature inside. Please find out from pundits of aviation engines. Say 2000 degrees centigrade, 3000 degrees centigrade. A very interesting thing happens inside this conical wind tunnel. The pressure inside the tunnel reduces. because the particles inside that tunnel are being fast burnt up, creating vacuum and change of matter into a gaseous state of whatever is inside that air, inside that conical structure. I hope you understood this to some extent. And again, it's a conical structure. Study the pressure inside that under highly heated conditions. The pressure at the small aperture will be much lesser than the pressure at the large circumference. Why? Because when I have a burner which is burning it to a very high temperature, the space or the volume between that burner and that small aperture is much lesser than the volume between the burner and the large circumference of the cone. So there is a huge pressure dip because of increased temperature near the small aperture. Under such a under such a deviant pressure condition, atmospheric pressure is much higher than the pressure inside the chamber. I find the flow of wind. I don't want to use it is a wind, a air. They say flow of air. You please forget that word air and say a wind flows through it. What a beautiful phenomenon. Wind, I'm creating a wind by heating the air inside that to a very high temperature. That's why when you see some aircraft or fighter jet engines, fighter jets, when they take off, you can see some kind of an exhaust of a red nature coming from the rear of the aircraft. That's a different engine by itself. I think I need to study it more. Now this much is clear. I have a conical structure, and I am heating the temperatures are very high. The temperature towards a small aperture, the pressure at the small aperture will be much lesser than the pressure at already there's a pressure differential at the larger circumferential end, creating a huge pressure differential, creating a wind. The air around this conical structure begins to gush into the conical structure, creating flow of air, creating a kind of wind which could create a whistling noise because the air is passing through a small aperture. This is the most important fundamental principle of jet engine. If Sir Frank Whittle were to sit in one of these classes where the jet engine is taught, the faculty, for good or bad, starts with these three components of compressor, combustion chamber, and turbine, without touching on what I'm saying, because the starting point of a jet engine is here. And starting point of many gas turbine engines is here. Forget the gas turbine engine part, look at the simple engine, what we call jet engine. Now I'm trying to work on the economics of the whole situation. I'm creating, but how to create this wind at lesser temperature so that I can save fuel. I can increase the pressure of inside this chamber manyfold. Again, the pressure must be higher at the higher circumferential end so that the air can flow into the smaller aperture much faster. Can I do it? Can't I do it? How can I do it? I do it by a compressor. It is some kind of a misnomer to use this word compressor in this context. What I am trying to do is that I am trying to block the flow of air. I'm trying to block the flow of air. I don't know. See, you should understand one thing. I just make some noise just to see that you feel better. I just got this equipment from somewhere and I'm just trying to learn playing it. Now look at this. If I block the flow of air, pressure increases. If I put any kind of a damming effect for the flow of air, pressure will increase. How do I increase pressure before the air reaches the combustion chamber, combustion part of combustion chamber, if you want to use that word? Strictly speaking, there is no chamber there. There's a combustion device. I know pundits of engines. I have not opened an aircraft engine and seen. People who have opened aircraft engine will know better. If I'm wrong, I stand corrected. But I'm looking at the common sense viewpoint. Now, if I block the air that's entering by say 2 3 cylindrical drums, by the way, I have to tell you two things. What are the two most important good inventions of mankind? First is the wheel, second is the impeller. This impeller, I don't want to spend time because let's focus on this engine, on gas turbine engine. Gas turbine engines don't use, they use impellers of the fan when it comes in. Okay, don't worry about it, but that's not an important component of gas turbine, yeah, of this jet engine. So suppose I were to put, I'm giving common sense, 3 4 discs. I've got a combustion device. I can shaft it. I can mount it on a shaft. The shaft will begin to rotate. When air gushes inside, I can also put because it's coming in. I can put a turbofan device. I can put a fan there to that entrance. Like you see, most modern day engines have a turbofan. But when air, I should just understand it for this. Understand the basics of it. When the air gushes inside, if I were to have three kinds of circular cylindrical with holes in it, the incoming air in a full gush flow will have to go through these holes. When it goes through 2 3 layers of such circular, it's not a cylindrical device. Please don't use the word cylindrical. That's wrong. Yeah, to some extent cylindrical, but a kind of circular, small kind of cylinders, but very small circular devices. What happens is that the air pressure increases. I can have a shaft rotating there by putting a turbo fan to start with, so that when air comes in, it comes in through that fan. But you should understand how do I get a rotating effect because air is gushing in. When air gushes in, I can make a fan work. It's like your exhaust fan at your home. When you switch it on, it works in one direction. What's the exhaust fan when the air is gushing into the house? The exhaust fan definitely begins to rotate in the opposite direction. So I have got a rotating device that basically is slowly coming into shape, but air pressure increases. If when air pressure increases, I need lesser temperature to burn the fuel. Thereby, I'm saving the fuel that is entering. I'm saving on the fuel. So I've got two stages. I've got burnt. I know the combustion side on there, and on the larger circumferential side, I am increasing the pressure. When I increase the pressure, air again flows down this conical structure much faster. How can I get so you please understand? Oh, I understand these two things. Why pundits of jet engines say what we call uh, compressor on one side, combustion chamber on the other. Actually, it should start that way. I start with the combustion chamber. I understand combustion, where I get a huge pressure reduction inside that device. Then I'm using certain other methods to increase the pressure on the inlet side when of the wind tunnel as the wind comes in or as the air comes in a flow. Now, for all practical purposes, I have got high pressure inside this chamber, much higher than what it was before, of the air that is trapped inside. I hope you understand what I'm trying to say. It is a wind tunnel. Air will exit, and air exit through a small aperture, even much faster now because of increased pressure, because there is thrust. Creating thrust, not because there is thrust, creating thrust. This is how the most fundamental principle around which jet engine works. Now, if I were to put near the small aperture another turbine, you don't confuse this word with turbine. Please remove that word called turbine. This is where I use the word. I come across the word called as impeller. That's why I was using the word impeller. See, this impeller is a very important invention of mankind. I don't know if you can also use the word propeller. But this impeller is what you see, very simple thing, what you see inside a table fan. You see three pieces which are skewed. When I switch on the fan, as that skewed impeller rotates, it pushes air from behind the fan into the front side. It creates a gush circulation of air because of the impeller. The impeller is used in the propulsion of ships. I don't know which great man invented this because this is structure called as the impeller because I get thrust because of the impeller. I get thrust because of the impeller. I get thrust because of the impeller. I had gone on holiday to a place called Murdeshwar in Uttara Karnataka just for a day or two. It's exactly on the seashore, and I happened to meet some fishermen who were repairing a boat. And I had discussion with them. They showed me an impeller which they use to propel the boat, which is handheld. It has an engine, most probably it has an engine. But these small fishing boats, they told me it starts on petrol but runs on kerosene. They have some method like that. So it's a method. I saw in the inside the boat both a can of petrol and a can of diesel. I'm sorry, a can of kerosene. They use the petrol to start the engine. After that, they switch over to kerosene to improve to make it more cost effective because kerosene is less costly than petrol. Where you see your impeller is seen inside the fan. If you want to call that table fan, if you want to call that structure inside the table fan, you call it as turbine, no problem. But that word turbine may not be a right word there. Turbine has got other roles. So after the combustion chamber, if I were to put a fan kind of a device, an impeller kind of a device, as the shaft rotates, I have the system very similar to a table fan in my house. The turbine like structure pushes air out of a huge fury out of the small aperture, creating thrust. Please understand the pressure inside this small chamber of the jet engine is much higher than the pressure outside. The turbine or the impeller making the flow of air in one direction. It pushes the air into that means so I have a full-fledged wind tunnel which effectively works at a much higher pressure, thereby pushing air out of that structure, uh, creating thrust. I hope I have made myself clear because I found a serious concern in the way this concept called jet engine is explained. If you get an opportunity to see a jet engine, please see it. It's a small device. It will be delight for a mechanical engineer or an aviation engineer. The nut and bolt aspect of it might be very different. To assemble an engine, it would need quite a bit of engineering skill, but it's not as formidable as it looks. It's a simple structure. I tried to develop on it in various ways. The problem with this engine is that temperature inside, jet engine temperature inside is very high, which means that yeah, this is explains the compressor, the combustion chamber, and the turbine. And the pilot in the cockpit increases fuel supply to the combustion chamber. The temperature inside the combustion chamber increases much further, creating pressure drop. More air sucked into the wind tunnel, and therefore I get more thrust. Planes fly at very high speeds because in the air, this wind tunnel works much effectively. It even works by default, creating thrust. That's why aircraft fly at a much higher speed. Because once I am airborne, friction is less and air is plenty. I've got a device whose pressure is very less. Obviously, to the delight of the environment, air will gush into it all by itself. In flight also, when I'm flying also, air gushes in because of the reaction of my direction which I'm flying, increasing the air pressure inside the this conical engine structure, because I can have more air, thereby increasing thrust. That's why planes have plane engines. Planes are able to fly at a much higher speed because it is there's a self-supporting system. I only need to take it off once I'm in a high speed. It works automatically by itself because the fuel into it to some extent is the air. But of course, I need to heat the combustion chamber so that the engine continues to work. But because I need to create a low pressure inside that system. That if the pressure goes, if the low pressure is not there, there will be no air gushing inside. The engine will, for all practical purposes, will not work with full thrust. Even if I switch off the engine, don't worry, I was never a pilot because I can never explain fire first-hand experience. But this is what basically a jet engine that we use in aircrafts that we see when we look at in airports works. It's a marvelous device working on a very simple principle. They say jet engines. I hope I have made justice to that so that you please understand. Because there are many people who talk about jet engines. Please have a look at it. But this, I'm just trying to go into the most fundamental aspects of it so that you have a very instant understanding of things. Even when you listen through lectures in some in engineering technical institutes, you can understand. But see, anyone who is to the aviation line who wants to have a first hand, a simple of understanding of what this is all about, without going into the complexities of it, what I've told will really help you in a very large measure. So that there I've got a very fundamental. There I've explained this. This is how a jet engine works. How can I control the thrust and speed of a jet engine is a very nice question. If I reduce the fuel going into the combustion chamber, the pressure difference between the atmosphere and inside the chamber will be less, creating less airflow, thereby reducing thrust. If my common sense is right, I can even turn an aeroplane by differential thrusts on the left and right engines. If I give more thrust on the right engine and reduce the thrust on the left engine, I'm just giving a hypothetical case, the plane will turn right. I hope I made myself clear. The plane will turn towards the direction where the thrust is less. If the left engine thrust I am able to control reduces than right engine, the plane will turn leftwards. I have not been a pilot, but I'm just telling that the science of the matter could be that way, or could work that way. And conversely, if I reduce the thrust on the right engine, increase the thrust on the left engine, the plane will turn rightwards. I don't know how fighter jets swirl and roll and rotate in the sky. That is a matter of only fighter pilots can say because that's a different science by itself. So before so I've got what's but I've got other kinds of engines. Can I have a propeller fixed system to see so far I have not used the word gas turbine engine. I've only used the word jet engine. Jet engine becomes a gas turbine engine, I think, when I tap this rotating turbine or whatever you call at the end of this at the end of this aircraft engine, as we see in jet engine, and couple it with a propeller, obviously the engine dynamics will be different. Don't worry about too much. The way I mount the engine will definitely be different on the aircraft will be different. Don't worry about it too much. For all practical purposes, I'm looking at the A320 or the Boeing planes that you see, which I explained so far. The moment I can use this to connect it to a propeller, I've got a propeller driven device. Those are different kinds of, they're called as turbojet engines. I don't know what you call it, but they are definitely, they come in a class of gas turbine engines. If you might call it. I think jet engine, I know again that word called gas turbine engine is a misnomer according to me because there's no gas I use there. If the gas is air, you should call it air turbine engine. Sometimes the way we give nomenclature to things is may or may not be correct because I don't use any gas there. It's only the air I use. I might use gas in some other situation. Uh, but I here it's only air. But I can use what I want to emphasize is that this rotating motion of which these turbine faces, I can use it in another form to couple it with a propeller, and I can run a I can make an aircraft work also using a propeller driven system. But I am using coupling. I'm wasting energy. I'm wasting power. I need more fuel. The fuel efficiency of the system may not be that high. Large aeroplanes, the best thing is to have this jet engine that I've talked about because it works almost effortlessly in a very smooth and song-like manner. But I would like to hasten to add that internal combustion engine, what we see in the cars, were earliest used in propeller-driven aircraft. One very interesting, Antonov is the largest aeroplane that has been made, I think, which ferries cargo. Antonov of Russian aircraft, most probably the biggest plane ever made. This biggest plane ever made does not work on jet engines. It works on propeller-driven kind of system. It has got two propellers on either side of the wings. It's very nice to see it driven as a swirl at a speed of some 30,000 RPM, making this giant structure get into the sky. What a marvelous system. See, sometimes they say old is gold. Old is really gold because I would just like to see some of these propeller driven aircrafts also for various reasons, both more good than bad, that I've gone into this jet engine as we see today. But I can have IC engine also I can use to propel and a propeller and run propellers, and these propellers also can also make aircrafts fly, take off and land and fly. So hopefully I have a long-standing confusion. Actually, this thinking I've met some General Electric employees who were involved in this engine activity, and they were not able to convincingly explain to what to do. So that set me thinking. So I think to a large extent, if you have got any other inputs or to add on this, or if I made any mistake in the way I see this, I look at the whole thing from common sense. I hope anyone who sees this video in engineering schools and colleges will appreciate what I'm trying to say because I've given a very simple explanation um, of a jet engine. This is P.O. Subhash from Bangalore, India. Thank you.